In this video, we're going to look at doing some estimating. So the first question we're going to look at is to estimate the number of times that your heart beats in 1 year. So obviously our heartbeat changes throughout the day, whether we're sleeping or exercising. So it'd be pretty tough to actually count the number of times your heart beats in 1 year. But how could we go about estimating the number of times that your heart beats in 1 year? So why don't you pause the video for a second and think about how you might approach that. All right, well, you probably thought I need to take some measure of my heartbeat. So maybe you want to take your heartbeat for 1 minute. And, it should be not when you're sleeping or not when you're exercising if you're going to use this as an estimate. So maybe get up, walk around the room a little bit, and then take your heartbeat and see how many times it beats in 1 minute or some time period. I wouldn't go less than 1 minute, but you could do 2 minutes. Or now I want you to actually do this. All right, we're actually going to do the estimation, so it's going to be a little bit different for everybody. All right, so if we start with 1 minute, then we can kind of scale that up and figure out how many heartbeats or estimate the number of heartbeats in a year. So pause the video and go take a quick little walk around the room and then count the number of times your heart beats in 1 minute. All right, so I just did mine and mine came out to 82 beats. Okay. Little high. Maybe I'm a little too much caffeine. We won't judge. We'll just write it down. All right, so 82 beats per minute. Now I'm going to do this in a mathematical way using unit analysis and scaling this up. So let's say I want to scale this up to an hour. All right, so we know that there are 60 minutes in 1 hour. So this technique is called unit analysis. This fraction that I wrote here in red is equivalent to 1. 60 minutes divided by 1 hour is 1. So I'm really multiplying my beats per minute times 1, which doesn't change the value. It's just going to change the unit of measure. All right, so the minutes are going to cancel out. And now I take 82 times 60. We'll get my handy dandy calculator. 82 times 60, and we get 4,920. Okay, so now I'm up to 4,920 beats per hour. All right, I've got hours left here, and the minutes are gone. So we want to continue this scaling until we get up to a year. So what are we going to do next? Probably days, right? So how many hours are in a day? Maybe we could do this all at once now, instead of one at a time. So we know that there are 24 hours in 1 day. So the hours will cancel and that'll get us to a day. And then we'll just say this isn't a leap year and we'll say there's 365 days in 1 year. All right, so the days are going to cancel. So now for my units of measure, I'll be left with beats per year, which is exactly what I want. I'm going to have beats per year, and now you just need to take out your handy dandy calculator, whatever your numbers are, and do the multiplication. I'll do mine times 365. 43 million, holy mackerel. What was the other numbers? 43,999,000. I didn't leave enough room. 99,200. 99,200. All right, so if I'm estimating, maybe I would estimate, because it is estimating, right? 43 million beats per year estimate. That's a lot. Then you could expand that out to a lifetime, right? How many would it beat if you lived to be 80 or whatever, estimating? All right, so that's an example of how we could estimate. And there's no exact right answer. There's certainly be some bad estimates or some better estimates. But that's kind of the deal with estimating, right? You just want to make a logical argument. Okay, let's look at the next one. Estimate the thickness of a single sheet of printer paper. Well, you certainly would have a hard time measuring a single sheet of printer paper because we don't have a measuring device that tiny handy. Are there measuring devices that tiny? Sure. You know, you could take some sheet of paper and there's probably some caliper thing that you could, you know, put on each side, but that's probably not in everybody's drawer. So how could we estimate? Well, one way we could do it is to take, you know, a package of paper like this. This is a little hard to see, but this contains 500 pieces of paper. So what would we need to do to estimate the thickness of a single sheet of paper? Yeah, I think you got it, right? We'd want to measure this. We could certainly measure that. I don't know what it is, but you could grab one. Let's say it's 2 inches. Okay, so we get 2 inches for 500 pieces. So we want to figure out how many inches per piece. And we know that there's 2 inches in 500 pieces. So we have to take 2 divided by 500. That's kind of a weird number, isn't it? Not weird, but tiny. 2 divided by 500 is 0.004 inches. 0.004 inches per piece. Now, if we were in the metric system, you know, like maybe we're doing centimeters, then I would probably convert that to a smaller unit of measurement like millimeters. But with our system, inches is the smallest unit of common measure, so I'd probably just leave my answer like that. All right, next question. Estimate the weight of a single sheet of printer paper. Well, we would want to find the weight of this. So we could take this guy and just put it on a scale somewhere and see how much it weighs. But in my investigating, I found a pretty interesting fact on this website, How Stuff Works. You know, sometimes you buy paper and it's called like 20-pound bond or 10-pound bond. It kind of refers to how the paper feels, its thickness, its sturdiness. Well, turns out it actually means something. I learned this today. The way we talk about paper in the United States is amazingly convoluted. The short answer is that 500 sheets of a 20-pound bond paper with a size of 17 by 22, and that's pretty big. That's bigger than our normal size paper. If I have 500 sheets of that, it weighs 20 pounds. That's why it's called 20-pound bond. So the manufacturer would take this sheet, this big sheet of paper, and if we cut it into 4 pieces, how much, what would be the dimensions of each piece? Well, half of 22 is 11, and half of 17 is 8.5. How about that? So we get 4 8.5 by 11 pieces of paper with this, which is our standard size. Okay, so let's think about this now. If this big old stack over here, if this 500 pieces were 22 inches by 17 inches, if they were big old pieces of paper, then this thing would weigh 20 pounds. Okay, so how much would a stack of paper that's 8.5 by 11 and 500 pieces weigh? Yeah, a 500 sheet ream of 20-pound bond paper would be 5 pounds because it would be 1/4 of that, right? We'd cut it like this and cut it like this, and this would be an 8.5 by 11 piece, which would be 1/4 of the weight, which would be 5 pounds. I didn't know that. How about that? So when you read this, it's telling you, you could divide that by 4, and that's how much 8.5 by 11, 500 pages would weigh. So 500 pounds, 500 pounds. No, I don't want that much paper. 5 pounds for 500 pieces. If I divide that, I get 1/100 pounds per piece. Or we could write that as a decimal, 1/100th of a pound per piece. Now we could convert this to a smaller unit of measure, which would be ounces. Do you remember how many ounces are in a pound? 16. Let's do that conversion. 16. Okay, so now if I want to convert this to ounces, I know there's 16 ounces per 1 pound. So then I would cancel these pounds, and I would take 0.01 times 16, which is going to move the decimal 2 places, and I would get 0.16 ounces per piece, which is still very, 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 very small, right? An ounce is pretty small. Okay, well, I hope these examples of estimating were somewhat interesting and give you some ideas about how to go about estimating.